Hey class, in today's lesson we're going to talk about counting principles, which is found in section 9.6 part 2. Our objective is to use permutations to solve counting problems. Okay, so the definition of a permutation is that a permutation of n different elements is an ordering of the elements such that one element is first, the other is second, the other is third, and so on. So the main thing that you need to learn about permutations is this keyword ordering. Okay, so to actually find the number of permutations of an element, of n elements, essentially what you do is you multiply the amount of elements using n factorial. So you'll see this in action. If the formula doesn't make sense, just take a look at the next example. And again, this gives you the different ways that elements can be ordered. And again, the key word is ordered. All right, so in example 5, it asks for us to find the number of permutations. So it says, how many permutations are possible for the letters A, B, C, D, E, and F? Okay, so again, this means the possible ways and the possible different ways that I can order these letters. So, again, a permutation is about differences in order. It doesn't want any repeats, okay? So for us, for the first position, there are 1, 2, 3, 4, 5, 6 positions. So for the first position, there are 6 letters as an option, okay? For the second position, because nothing can or should be able to duplicate, now there are only 5 letters to choose from. Okay, it follows the pattern that the third is 4, the fourth would give you 3, the fifth would give you 2, and the sixth would give you 1. So essentially what we would do is we would multiply these 6 times 5 times 4 times 3 times 2 times 1, which is the same thing as 6 factorial, and we will get 720 possible letters. Really possible permutations, but kind of got lazy. All right, let's take a look at the next one. So to take a certain number of elements at a time, we're going to use this formula. So it's n factorial over n minus r factorial. And again, this is for permutations. And we know that because we see the letter P for our formula. All right, so for example 6, it says counting horse race finishes. So it says 8 horses are running in a race, and how many different ways can these horses come in first, second, and third place? Assume that there are no ties. So if there are 8 horses, the possibilities for first place are 8. Any of those 8 horses can get first place. Okay, for second place, because there was already a first place, now there are only 7 horses that can get those spaces or that place. And then third place, again, because there is a first and a second place, now you only have 6 horses left that can get that spot. So essentially what we did was 8 times 7 times 6, which is 336. So there are 336 different ways. Okay. The other way of doing this exact same problem is to use the formula. So that would be 8 factorial over 8 minus 3 factorial. 8 factorial is really 8 times 7 times 6 times 5 times, and actually, let me back up so that it looks all together. So that's going to be 8 factorial over 8 minus 3 is 5, so it's 5 factorial. So what that would look like is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 5 times 4 times 3 times 2 times 1. Because they are like terms in both the numerator and the denominator, we still get the same situation, 8 times 7 times 6, which is 336 different ways. Okay, let's look at the next problem. This time we're talking about distinguishable permutations. And so this happens, it says, suppose a set of n objects has n sub 1 of one kind of an object, n sub 2 of a second kind of object, n sub 3 of a third. However many different distinguishable permutations, we would use this formula. And so the denominator depends on how many differences there are. And again, we will see this in action on example 7, which is our last example. So it says, in how many distinguishable ways, so this is nice, they give you keywords, distinguishable ways can the letters in banana be written? So first of all, to use the formula, it said n factorial over n1 factorial, n2 factorial, dot, 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 up to nk factorial, right? And so n means the letters in banana. Okay, and the amount of letters in banana is 6, right? Okay, so then n sub 1 would be how many B's are there? Okay, so there's only one B. N sub 2 would be the amount of A's that there are. These are different letters, right? So the amount of A's that there are is 3. N sub 3 would be the amount of N's that there are, and there are 2 N's. So to put this formula into play, we would have 6 factorial over 1 factorial, 3 factorial, and 2 factorial. And I just put it in the order literally that we were given. So that would be, if I work that out, 6 times 5, that was bad, 6 times 5 times 4 times 3 times 2 times 1 over 1 times 3 times 2 times 1 times 2 times 1. Okay, this 3, 2, 1 is going to cancel with that 3, 2, 1. 6 divided by 2 is really 3. So we're left with 3 times 5 times 4, which is 60. So there are 60 distinguishable ways. Alrighty guys, if you have any questions about this lesson, please be sure to come see me for tutoring.